Hi class. In this video here, we're going to start talking about section 3.1 titled Beyond Numbers and talking about what does infinity mean. All right. So before we get into the concept of like infinity and going on forever, we have to begin somewhere. All right. And it actually begins with counting. Okay. And so what we want to do is we want to count infinite collections. Okay. But we don't know how to count that high. Like if someone says count to infinity, you're like, what does that mean? Like you just keep going forever, right? Like infinity is a concept. It just means keep going forever. So we can't count to infinity. So thus what we're going to do is we're going to seek different ways to count collections of ordinary objects in the hope that one method might work for infinite collections as well. And so like what this talks about here is this idea of a one-to-one correspondence. And we're going to use this concept of a one-to-one correspondence when we start talking about infinity. Okay, so here's a textbook, okay, for the textbook definition of a one-to-one correspondence. So if you have two collections whose objects can be paired evenly, okay, that means one from one collection with one from the other collection. They're said to have a one-to-one correspondence, okay? I thought this formal definition was a little bit better, and I won't read it just verbatim, but kind of like illustrate it here. So it talks about two collections. So suppose you have collection A, which is the numbers 1, 2, 3, 4. And then you have this other collection B, which is lowercase a, b, c, d. If you can pair the numbers so that one item from A matches to exactly one item from B, or you could go the other way, okay, so that each item pairs only to one other one, okay, then you could say you have a one-to-one correspondence. Very straightforward concept. If I have 4 collections in A, 4 collections in B, and I pair it so that each one goes to the other one evenly, okay, all right, then you're said to have a one-to-one correspondence. All right, so here's a textbook example to illustrate the idea of a one-to-one correspondence and how we're going to eventually use it. All right. So suppose you have a huge barrel of these Volvos, these cars, okay, and a barrel full of soccer balls too, okay? And we want to know if there are more Volvos than soccer balls or more soccer balls than Volvos or the same number of each, okay? So how can we decide? Well, what you could probably do is you just count the number of Volvos and soccer balls in each barrel and compare the two numbers, right? Like if there's, I didn't actually count these, but let's just say there's, 10 Volvos and then 10 soccer balls. You're like, oh, they're even. Okay. All right. So certainly that method works. But an alternative method that we're going to illustrate here allows us to grapple with magnitudes that we can't count. So like when we talk about things that have an infinite number of objects in them, okay, we can't count that, right? So what we could do is you could take one Volvo from the first barrel and one soccer ball from the second barrel and pair them up. So like put the soccer ball in the trunk. And then you could do it again. Then you could take another Volvo from the first barrel and then another ball from the second barrel and keep pairing them up, okay? So 1 to 1. I take one Volvo, one soccer ball, put them together. One Volvo, one soccer ball, put them together. And without actually counting anything, if you saw that like it ended up evenly, you could say, oh, yeah, I have the same number of Volvos as soccer balls. Okay, or if there was like you couldn't do it and there was one left over, you'd be like, no, I have one more Volvo or something like that. All right, so that's just like an illustration of this idea of a one-to-one correspondence. If I could take the two objects, one object from this barrel and one object from this barrel and team them up and do it so it all evens out perfectly, then you would have a one-to-one correspondence. That's the whole idea here, okay? And so as we explore this notion of one-to-one correspondences, especially in the remaining sections, we're going to talk a lot about it, all right? You must do something that is extremely difficult. You must forget, okay? And what I mean by that is you must forget that 8 means something, and you must forget that 37 means something. So you got to strip from our minds the names of numbers, leaving behind only the idea that two collections of objects are equally numerous, precisely if there's a one-to-one correspondence between those elements of the two collections, okay? So like the way you would think about it, in taking this step, we're moving away from thinking of a number as an attribute of a collection, like I have 5 fingers on my right hand, okay? And then what we're going to be doing in future sections, all right, is thinking of this. I have just as many fingers on my right hand as my left hand because I can touch all the fingers. And like it's weird, like you can't see it, but as I'm recording this lecture, I'm doing this with my fingertips, and hopefully you might too. I can touch all my fingertips on one hand with the fingertips on the other hand. All right. And it's like, in my mind, I'm like, I don't have 5 fingers in each hand. I'm like, wow, look, they all match up perfectly. And I have a one-to-one correspondence between the fingers on my hands. All right. So let's do another, just a visual of this real quick. I'll do a visual problem and then I'll do actually a mindscape problem. So a problem from your textbook. Okay. So here's the first question. Which one of these, all right, I have two situations here. Okay. Shows a one-to-one correspondence and which one does not. Okay. So remember what a one-to-one correspondence means. It means element from set A here in this case maps to exactly one of set B. So if you look here, I'm mapping 5 to 7, 6 to 8, 7 to 9, 8 to 10. For whatever reason, this is how I set it up, the correspondence, and that is a one-to-one correspondence because each item in the first collection corresponds to exactly one item in the second collection. Done. This is a correspondence. This is a one-to-one correspondence. But now if you look at this, you can see right off the bat that this is not a one-to-one correspondence. Because for whatever reason, this barrel or collection of C, which is the numbers 2, 4, and 3, and D is 20, 30, 40. The number 2, I'm saying, corresponds to both 20 and 40. So this is not a one-to-one correspondence. Okay? All right? Here you can see that each number is connected to only one other. Here 2 goes to 2 different ones. Not a one-to-one correspondence. All right, let's try this one. Okay, and some of the problems from the textbook, these mindscapes, require you to kind of like think outside the box. Okay, this is called dorm life. All right, every student at a certain college is assigned a dorm room. Okay, so like imagine, traditional college setting. When I went, for example, when I went to undergrad, I went right at 18, and I went to college and I lived in the dorms, so I got assigned a dorm room. All right, so every student is going to one dorm room. Okay. Does this imply that there's a one-to-one correspondence between dorm rooms and students? Explain your answer. Well, initially it might seem that way, the way it's written. It might be like, well, yeah, each student goes to one dorm room. But notice how the explanation doesn't say how many students are in each dorm room. Okay. So one student, like here, this one student is going to a dorm room. But another way you could think about it here is like, look at this. Suppose this is dorm room. All right, we'll just call it dorm room 40. This is saying something like student, and imagine that this first line isn't up there, but this is saying student 2 is defined to 40, dorm 40, and student 4 is defined or assigned, to room 40. So that would mean there's not a one-to-one correspondence. Like, for example, when I went to college, I had a roommate. Okay. So there were 2 different students assigned to one dorm room. Okay. So that's not a one-to-one correspondence. Like if every student had lived alone in the dorm rooms, then every student would have got a unique dorm room and it would have been a one-to-one correspondence. But here it's tricky how it's written, but since it doesn't specify that students live alone, multiple students could be assigned to a dorm room. So no, this is not a one-to-one correspondence. All right, class, we'll continue with this concept of a one-to-one correspondence as we move into the future sections, talking about sets that are infinitely big.